We're on problem 67. They ask us, how many terms does the binomial expansion of x squared plus 2y to the third to the 20th power contain? And so right when you see, oh my god, to the 20th power, you might say, oh, that'll take me forever to do, and then I'll have to count the terms. But remember, they're just asking you how many terms. They're not asking you to find the expansion. So you just have to say, oh boy, let me just think about this a little bit. And just think of it this way. X plus y to the first power has how many terms? It has, well, it's just x plus y, right? It's just x plus y. And so it has two terms. X plus y squared, that is equal to x squared plus 2xy plus y squared. So that has three terms. If I were to do x plus y to the third power, I could do a binomial expansion. I could do it with Pascal's triangle. Let me do it with Pascal's triangle. I have the 1 and the 1. That's to the first power. And the second power, those are the coefficients. Then the third power, the coefficients become 1, 3, because 1 plus 2 is 3. 3, 1. And actually, I don't even have to expand it out. I'll do it just for a little practice. It's x to the third plus 3x squared y plus 3x y squared plus y to the third. I just use these. But when you take any binomial and you take it to the third power, you end up with 4 terms, right? And depending on how you think of it, if you think of it with Pascal's triangle, every time we go down, we're just going to be adding another term, right? When we take the fourth power, it's going to have 5 terms. Or when you think about just when we use the binomial expansion, and you might want to watch some videos on that, there you also have, if you're taking it to the nth power, you end up with n plus 1 terms. So in this example, we have a binomial. Binomial just means a 2-term polynomial. And we're taking it to the 20th power. If we're taking it to the third power, we'd have 4 terms. If we're taking it to the fourth power, we'd have 5 terms. So if we're taking it to the 20th power, we're going to have 21 terms. And that's choice B. Next problem. Next problem. All right, they want us to keep doing these, and we'll do it because they want us to. All right, what are the first 4 terms in the expansion of 1 plus 2x to the 6th power? And here we'll just use the binomial expansion because I think that's what they want us to do. And that's probably the fastest way to do it. So let's just think of the coefficients first. So this is going to be, well, let's just do it. This is going to be equal to 6 choose 0. And we're just going to do the first 4 terms times 1 to the 6th times 2x to the 0, so I don't have to write that, plus 6 choose 1. And actually, we'll probably just have to figure out the third term because that's the only time where they start to change. 6 choose 1 times 1 to the 5th, right? 1 to the 5th power times 2x to the first power times 2x plus 6 choose 2 times, I mean, these ones, it doesn't matter what power is it. 1 to the 4th times 2x squared plus, let's see, they want the first 4, so let's do the last one. 6 choose 3 times 1 to the 5th times, 1 to the 3rd. You have to decrement the 1 every time, times 2x to the 3rd. All right. And if we look at the choices, just to save time, if we look at the choices, okay, we agree that the first term is going to be 1, so that we can definitely say is going to be 1 because all the choices are 1. The second term is definitely going to be 12x. And then we start getting some disagreement on the third term. So let's see what the third term. 6 choose 2. That's equal to 6 factorial over 2 factorial over 6 minus 2 factorial. Let me scroll down a little bit. So that is equal to 6 factorial, which is 6 times 5 times 4 times 3 times 2 times 1, but the 1 doesn't change anything, divided by 2 factorial, which is 2 times 1, or just 2, divided by 6 minus 2 factorial. That's 4 factorial, so times 4 times 3 times 2 times 1. That cancels out with that. The 2 and the 6 cancel out, and you get 3. So you end up with 3 times 5. So you end up, so the 6 choose 2 becomes 15, right? 3 times 5. That's 15. times 1 to the fourth, which is 1, times 2x squared. So times 4x squared. And so that's 15 times 4, that's 60x squared. So the third term is going to be 60x squared. And we're done. This is choice D is the only one that has 60x squared as the third term. So we're done. We didn't even have to go to the fourth term. So if we, by carefully looking at the choices, we actually only had to evaluate one of the terms. Next problem. Let's see. All right, problem 69. They say, let me copy and paste it. What is the sum of the infinite geometric series 1/2 plus 1/4 plus 1/8 all the way over there? I'll be frank. Well, I do now remember the formula, but a lot of times in life you might forget the formula, and there's a trick to reproving the formula for yourself, just in case you forget it when you're 32 years old like me. So let's say that I'm trying to find the infinite sum of a geometric series. So let's say that the sum, and I'm going to reprove it right here in the midst of this test. And I've done this in the midst of tests, and it saved me. So it's nice to know the proof. And it actually impresses people, if you know people who are impressed by proofs. So let's say the sum is equal to a to the 0, a to the 0. Well, actually, let's say, well, see, this is interesting because they're starting at 1/2. Actually, let's just do the concrete numbers because we want to figure out this exact sum. So let's say that the sum is equal to 1/2 to the 1 plus 1/2 squared plus 1/2 to the third. It's the whole 1/2 to the third, right? Plus, and you just keep going, right? Fair enough. Now let's take 1/2 times the sum. So 1/2 times the sum. What is this equal to? Well, if I took 1/2 times this whole thing, now 1/2, I would have to distribute it over each of these terms. So 1/2 times this term, times this first term, 1/2 times 1/2 to the first, well, that's now going to be 1/2 squared, right? 1/2 squared, right? All I did is I'm distributing this 1/2 times each of this term. 1/2 times 1/2 to the first, that's 1/2 squared. Now 1/2 times 1/2 squared, well, that's going to be 1/2 to the third power, right? And it just keeps going. You're just going to keep, it's an infinite series, right? So, let me ask you something. If I subtracted this from that, what do I get? Let's see what I get. So I get s minus 1/2 s, right? I'm subtracting that from that, is equal to this minus this. Well, if I'm subtracting the green stuff from the yellow stuff, this is going to cancel out with that, that's going to cancel out with that, and all I'm going to be left with is this first thing right here. All right, that's the trick, and you could prove it generally for any base. And I thought it was interesting because a lot of times they start with the 0th power, and this problem was interesting because they start with 1/2 to the first power. But anyway, let's figure this. S minus 1/2 s, well, that's just 1/2 s. 1/2 s is equal to 1/2, and then you have s is divide both sides by 1/2, or multiply both sides by 2, and you get s is equal to 1. Now, a lot of you may, there is a formula where it says, let me tell you what the formula says. The formula that you may or may not have memorized is if you start at n is equal to 0, and if you go to infinity of a to the n, right? In this case, a is 1/2, that this is going to be equal to 1 over 1 minus a. So your natural reaction would have been, oh, okay, well, that sum that we saw, that's equal to the sum of n is equal to 0 to infinity of 1/2 to the n, which would be equal to 1 over 1 minus 1/2. What's that? 1 minus 1, that's 1 over 1/2, which would be equal to 2. And you'd be like, my God, what did I do wrong there, right? And I'll show you what you did wrong. This sum that you took the sum of, remember, n is starting at 0, so this sum that sums up to 2 is 1/2 to the n, 1/2 to the 0 is 1, plus 1/2 to the 1, 1/2, plus 1/2 squared, 1/4, plus 1/8, so on and so forth, right? That is equal to 2. That is equal to 2. This problem, and that's why it was a little tricky. This problem, they didn't want this sum, they wanted this sum, 1/2 plus 1/4 plus 1/8 plus so forth and so on, right? So they wanted everything but this 1. So if you subtracted this 1 from both sides, then you would say, oh, okay, this sum must be equal to 1, which is the answer we got that way. So that's why sometimes, memorizing formulas, this formula is a nice formula to memorize. It's very simple. But it sometimes becomes really confusing when you're like, oh boy, but this is when n starts at 0. What happens when n starts at 1? And to some degree, I really like this problem because it's testing you to see if you really understand what the formula is all about. Anyway, I'll see you in the next video.